Hey everyone, welcome back to the channel. This is Rahul. So it's been a long time that I shared one video. So we are starting from today again. So as part of that, I chose one DSA question, that is do sum. Why I chose that one? Because when I search for rank level interviews, the most asked question is do sum. But it's actually an easy one. So I thought we can start from that. And in this twosome I will explain the way we can approach this question, and if we are in an interview, if we get this question, how we can um, tell this answer to an recruiter. So in that way I will explain. So let's start. So this is our question, twosome. So we have one array nums, which is integer, and one target integer. So the task here is to return the indices of the two numbers which will add up to the target. So to get the clear idea, just see this example. Here the array is 2 7 11 15 and the target is 9. So it's nothing but when we add any two um, elements, any two elements in this array which will give the target 9, then we have to return the indices. So that's the approach we have to do. So there is one condition, which means you may assume that each input would have exactly one solution and you may not use the same element twice. So we have to take one element on only one once. Okay. So and we can return the answer in any order. They didn't mention which order we have to give. The first one have to be the first, like that. So the idea is simple. What we can do here. So at first we can use brute force approach, but the issue is it will take big of n square time complexity, which is a worst thing. So we can do one thing. So as part of that, using one pass, we can find the solution by using a hash map, which will allow us to store and look up the value in a constant time, which will give the time complexity of big of 1. So as part of that in hash mapping, what we are doing is we have to go for each number, then we have to find its complement, which means we have to find the difference between the target and the current number. Then we have to check if this complement is already exist in the map. Then if it does, then it means that we have already seen that number. Then we have to add the num which gives the target. So we will return both the indices. Then the second condition, which means if it doesn't, then we store the current number and its indices in the map, so we can potentially find it later. So this is the approach we use, which will avoid the nested loops, as I already mentioned, which will take big of n square time complexity, where n is the array length. So let's start with our coding part. So as you can see, we have the integer, we have the method toSum with the two parameters nums array and integer target. So first of all, we have to create a hash map in order to store the number and the index. So first we can start with that, and you can name as your wish. So I just giving it as map only, hash map. So once this done, we have to traverse the array in order to find the elements. So for that we can use the for loop, the simple one. Int I to 0, I the nums dot length. So once this done, we have to calculate the complement. So int complement is equal to target minus nums of I. Okay. Once this done, once we calculate the complement, then we have to check if the complement is already in the map. So if map dot contains key complement, then we have to which means if we found then we have to return the indices. Return new array get complement, then I. So the second condition, if it's otherwise we have to store the current number and its index. So we will use the put. I. Okay. There is another one more condition is there, which means if we didn't found any solution, then we have to um, return one empty array. Even though the problem guarantees we will get one solution, but we are just using it because here they given this way, but when it comes to a exam or a test case pattern, they will give some other conditions. So we have, for the safety part, we will use one empty array. So this is the thing. So it's working fine. When you check this complexity analyze, you can see big of n, big of n. So these things you can check whenever you write one code to check your complexities, both for uh, time complexity as well as space complexity, which will help you for optimizing your solutions further. So I will just give you why it's big of n here. As you know, we traverse the array once, and the space complexity because we store every element in the map. That's the worst condition. If it's found, then there is no need of the second condition like this one. Okay. So when you get this question in an interview and you have to mention this to the recruiter, then you can mention like um, for the do some problem, because whenever you get an question you have to mention the question that you got. That's a best part. So for the do some problem, I used a hash map to achieve an efficient solution, which is use the one pass. So once I iterate through the array, for each number I calculate its complement and the value that would add up to the target. So Once this done, I check if this complement has already been in the map. If it has, then I will return the indices immediately. If it not available, then I add the current number and the index to the map. This approach gives me a linear time complexity of big of n with the big of n space for storing scene elements. So using a hash map um, was key to ensuring constant time lookups for uh, rather than using brute force approach. So in this way you can mention this approach to the recruiter. So if you have any query or anything, just ping me, I will help. So till that, see you in next video. Bye.